Hi everyone. In this video, we're going to be doing A-Level Maths 9709, paper 51, Probability and Statistics 1 October, November 2025. This paper is 1 hour 15 minutes long, so we'll try to finish within that time limit. So let's get started. Okay, so for the first question, we're told that the random variable x takes the value x with probability kx squared, where k is a constant and x takes the values -2, 1, 2, 3 only. Okay, for the first part, we're supposed to drop the probability distribution table for x, giving probabilities as numerical fractions, so we cannot express it in terms of k. Okay, so first off, let's start off by drawing our table. So to draw your probability distribution table, there's two parts to it. One where you first row where you write down the values of x, and then second row where you write down the probabilities of the random variables x. Yeah, so you write it with the header px, a big X equals to small x. Okay, now in our first row, we're going to write down our x values -2, 1, 2, and 3. Okay, so for probabilities, since we cannot give them in terms of k, we first have to find out what k is, and then we'll write down our probabilities. Okay, so let's start. Okay, so there's one so uh, there's one property for random variables. Okay, so if you add up all the probabilities of each and every single random variable, you will get a 1 when you sum them all up. Okay, so that's what we're going to do. So a -2 squared. So we'll substitute each value of x, and then k1 squared plus k2 squared plus k3 squared. And this will equal to 1. So yeah. And then this one is 4k, 4k again, 3 squared, that's 9. So 9k equals to 1. And you'll get 4 plus 4 plus 10. So 8 plus 10, you get 18k equals to 1. And k, you would get 1 over 18. Yeah, so now since we found the value of k, we can write down the probabilities of each of the random variables. Okay, so here it's going to be kx squared, so 18 times -2 squared. So that is 4 over 18. So simplifying that would give you 2 over 9. And then here is 18, 1 squared, which is just 1 over 18. And then here should be also the same, 2 over 9. Yeah, because 2 squared and -2 squared, they're the same. And here it'll be 1 over 18 times 3 squared. So that gives you 9 over 18, which simplifying gives you half. So this would be our final answer for the first part. Let's move on to the next part. Okay, so for this part, we're told to find the expectation of x, or EX. Okay, so to find that, go to your MF19. There's a formula for EX that you can use directly. Okay, all right. So it's under discrete random variables. And yeah, here it is. So it says EX is the sigma of XP. So what this means is basically it's the sum of all the products of the random variables with their respective probabilities. So if you didn't get that, you'll get it in a very short while when I do it. So basically what this is saying is you take your x value and you multiply it with your probability, and you add all those up for the other values of x as well. So yeah, EX is just gonna be -2 times 2 over 9 plus 1 times 1 over 18 plus 2 times 2 over 19. Oh my, it's 2 over 9, sorry, plus 3 times half. So just multiply. You will get 14 over 9. Yeah, so this would be our answer for this part. Let's move on to the next part. Okay, so for this last part, we're told to find the probability of x not equals to 0, given that, so this is what this straight line means, given that x is more than 0. Okay, so to do this question, yeah, so since we're given the symbol, given that, the straight line, we're gonna have to use the formula for conditional probability. So yeah, you're gonna see how it's like in a minute. So the formula for that is these two events intersect. So the probability of x not equals to 0, and so this is what this symbol means, and x is more than 0 over x more than 0, probability of x more than 0. So this is the format. The denominator would always be the condition after the straight line. Okay, so let's find out the first probability, the probability that x is not equals to 2 and x is more than 8. Okay, so what's the probability that x is not equals to 2 and x is more than 8? Well, if we see in our probability distribution table, the only values of x that are not equals to 2 and more than 0 are 1 and 3. So we can just add the probabilities for those values of x to get this answer. So yeah, this would just be 1 over 18 plus half. That would be equals to 10 over 18, so you get 5 over 9. And as for the probability for x is more than 0, take a look at your probability distribution table and you would realize that all the values of x except -2 qualify. So the shorter way to get this would just be to take 1 and then subtract the probability of x equals to -2. So this would just be 1 minus 2 over 9, which will give you 7 over 9. And yeah, with that, we'll get a final answer of 5 over 9 divided by 7 over 9. So we'll get 5 over 7 for your final answer. Let's move on to the next question. Okay, so for this question, we are told that a fair six-sided dice with faces labeled 1, 2, 3, 4, 5, 6 is thrown repeatedly until a 6 is obtained. So from this first sentence alone, we can tell that we're going to be getting a geometric distribution because we are doing something again and again. So unlimited number of trials until we get our outcome that we intend. Okay, so for the first part, we're told to find the probability that a 6 is obtained for the first time on the 8th row. So this first part is a very straightforward geometric distribution question. Okay, so yeah, we just want to find the probability that we get 6 for the first time on the 8th row. Okay, so yeah, there's a geometric distribution, and the only parameter for geometric distribution is the probability of success. So since it's a fair six-sided dice, probabilities will be 1 over 6. Okay, and then we'll find the probability that probability of x equals to 8, where x is the number of throws. So to find that, we know that every attempt before the eighth row is a failure. So the probability of failure will multiply it 7 times. So 5/6 to the power 7, and then we'll multiply the probability of success. This formula is also given in your formula sheet, but it should be pretty intuitive enough for you to remember it. Okay, so final answer would be 0.0465 to 3SF. Yeah, so this would be our final answer for the first part. Let's move on to the next part. Okay, so for this second part, we are told to find the probability that a 6 is obtained for the third time. So now it's not the first time, on the seventh row. Yeah, so this question is not really a straightforward application of the geometric distribution. So to visualize things better, we're going to start off by drawing a diagram that shows us what we get on each throw. Like we'll just try to visualize. So our ultimate outcome is that we want to get a 6 on our seventh row for the third time. So before the seventh row, we must obtain 6 2 times. So yeah, this is 6. So that is fixed. And then everything else before the seventh row, it doesn't matter which throw you get, your 6 or not. Okay. So I can just make an arbitrary guess. So I can say that, okay, I get the 6 on my first row, and then I get my 6 on the second row as well. And then the remaining 4 rows, I don't get any 6s. So yeah, 6 prime. Okay, yeah. So as as you know, this is not the only possible arrangement of this. You can also have, let's say, you get 6 for the first time on the second row, and you get for the second time on the fifth row, right? So to find all the possible like arrangements that we can have, we're going to find a number of different arrangements that this arrangement can take. Yeah, so to do that, we're going to find the probability for this specific case. All right, so 3 6s. So 1/6 multiplied 3 times, so to the power of 3 times 5/6 to the power of 4. And since every single one of our arrangements will have the same number of successes and failures, we're just going to multiply the number of total arrangements for this. Okay, so that is going to be 6 factorial over the number of repetitions. So our repetitions are the 6 primes and the 6s. So that is 2 factorial over 4 factorial. Okay, now you just type this into your calculator. And you would get this as your final answer. You can write it in fraction. That's what I prefer to do, to always leave in exact form whenever possible. However, if you don't want, you can also leave your answer to 3SF, which will give you 0.0335. Yeah, so this would be our final answer for this part, as well as the entire question. Let's move on to the next question. Okay, so for this question, we're given a back-to-back stem and leaf diagram. Okay, and it tells us, it shows us the annual salaries in dollars of the 27 employees at each of the 2 companies, Browns and Greens. So on the left, we have all the salaries of the employees at Browns, and on the right, we have the salaries of the employees at Greens. Okay. All right, so for the first part, we are told to find the median and the interquartile range for the annual salaries of the employees at Brown's. Okay, so let's start finding the median first. So to find your median, if you have if you have like an odd number of data points, okay, you take the 27th in this case plus 1 over 2. You take the 14th data point, okay? Yeah, so the 14th position, that would be our median. So let's start counting. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that is going to be our median. So let's write down. So median is, oh, and don't forget the key here. So the key here tells you how to read the stem and leaf diagram. So in this case, they give you an example 6. So this is the lines in these lines, okay, 32, 7. So they mean 32,600 for browns. So 32,600 for browns and 32,700 for greens. 32,700 for greens. All right, so in our case, we have 32 and 4. So this would just be 32,400. All right. Okay, now let's find our interquartile range. So to find the interquartile range, the formula is Q3 minus Q1. So Q3 is basically the upper quartile. To know which position is your upper quartile in. So just like how we divided with 2 to get the median, your upper quartile, you add 1, okay, to the number of data points, and you multiply by 3 over 4, okay? You would get uh 28, 7, yeah, 21 position. And to get your lower quartile, you just do 27 plus 1 over 4, which will get you 7th position. Okay, so yeah, let's find our Q3 and Q1. So let's find the Q1 first. So 1, 2, 3, 4, 5, 6, 7. So 31 and 3, that gives us 31,300. And then minus the Q. Oh wait, sorry. Okay, never mind. That's Q1. So yeah, 31,300. Now let's find out Q3. So there's the 21st position. So let's start from here. 14, 15, 16, 17, 18, 19, 20, 21. Wow, all of them are below each other. Okay, so 33 and 5, that gives you 33,500. And therefore, the final answer would be 2,200. Yeah, so this would be a final answer for this part. Let's move on to the next part. Okay, so for this part B, we're told that the annual salary of an employee at Brown's is denoted by X $1,000, so not dollars only. And the annual salary of an employee at Green's is denoted by Y $1,000, so not just dollars again. And it's given that for the 27 employees at each of the companies, so we're given a bunch of symbols. So this just means the sum of X. So it's basically the sum of all the salaries of the employees at Brown's in $1,000. So to make things easier, we're gonna convert them to just dollars. So to do that, you just multiply by 1,000. Yeah, you'll get 8, 700, 300. And we're also given the summation of x squared. So for that, yeah, that's basically the sum of all the salaries squared. So all the salaries are squared before their sums are taken. And to get this in terms of dollars, instead of multiplying by 1,000, since we squared the x, now the unit has also been squared. So therefore, now it's actually to the millionth power. So if you want to get in terms of dollars, you just have to multiply by 10 to the power of 6, and you'll get a very big number. So for this, you get 2.861609 times 10 to the power of 10. Yeah. So let's do the same for these. And by the way, this isn't compulsory. It's just to make your life easier because your final answer should be in dollars anyway. So it's best if you prepare beforehand. Okay. And then for this, you would get 2.981563 to the power of 10. Yeah, so that's that. Now we're ready to find the mean and the standard deviation of the annual salaries of these 54 employees. Yeah, so now they want us to combine all the data from these two data sets into just one. So we need to find the combined mean and the combined standard deviation. So let's find the combined mean first. So for the mean, very simple. You just take the uh, sum of the two data sets. So you take sigma x plus sigma y, divide by the total number of data points from each of the two data sets. So they already gave us that's 54. So sigma x is 878,300 plus sigma y, that is 896,500 divided by 54. Yeah, so 78,300 plus 896,500 divided by 54. You would get 96,600 over 3, or since final answers and it's in dollars, you should round it off to the nearest whole number, 32,000, actually to 3SF, 32,900, okay, to 3SF. Yeah, so this exact answer I kept it because we need it later for standard deviation. Okay, so now for standard deviation, this one is slightly more complex because there's two formulas standard deviation. So now I'll show you which one, which one you should choose. Yeah, so as you can see, this is one of the formulas. So this one has sigma bracket x minus x bar, which is the mean. So x minus mean squared, the sum of all those over the number of data points. So this one is not suitable as we don't know the individual values of all the x's and y's. So we only can use the second formula that they gave us, which is sigma x squared over n minus x bar squared. All right, so this sigma x squared is just the sum of all the data points squared. All right, and then mean squared is just mean squared. All right, so translating into our context, so sigma x squared, that just be sigma x squared plus sigma y squared. And then over n, which is 54, minus the mean squared. All right, so add up everything. 2861609 plus, sorry, it's lagging a bit, times 10 to the power of 10 over 54 minus 98,600 over 3 squared. Okay, so now just type all this into your calculator. 2.861609 plus 2.981563 times 10 to the power of 10 over 54 minus 98,600 over 3 squared. Okay, yeah, so yeah, we got $1,360 to 3SF. So these two answers would be our final answers for this part, as well as the whole question. Let's move on to the next question. Okay, so for this question, we are told that bag A contains 8 red marbles and 3 blue marbles. Bag B contains 4 red marbles and 1 blue marble. All right, so here they said a marble is chosen at random from bag A. If marble chosen is red, it is discarded, so it's thrown away, never to be returned. So, and if a marble chosen is blue, it is placed in bag B. All right, and then after that, they say a marble is then chosen at random from bag B. If marble chosen is red, it's discarded. So same as the previous one. If the marble chosen is blue, it is placed in bag A. And then finally, a marble is now chosen at random from bag A again. Okay. So the first part, we are told to complete the tree diagram by entering all the remaining outcomes and probabilities. All right, so to do this question, let's start labeling all the outcomes first. So you can choose red here, so it'll just be red. This will be blue. Same for all the other branches, just red and blue and red, blue, red, blue, red, blue, red, and blue. Okay, so let's start with the red branch. So we chose red from bag A, and then now in bag B, we have red as well. So if the marble is red, it is, okay, so let's start from the beginning before we even start taking the marble out. So since in our previous bag A, we chose red, it is not placed in bag B. Therefore, the total number of marbles in bag B will still be 4 plus 1, which is 5. So it's still the same. So still 4 red marbles and 1 blue marble. Okay. Now let's do this. So now let's do the branch where we chose red in bag A, red in bag B, and red in bag A again. Okay, so since we chose red in bag B, it is not placed in bag A. So the number of marbles in bag A would be the same as before. So since we chose red like for the first time in bag A, it is discarded. So therefore, instead of 8 plus 3, 11 marbles, we'll have 10 marbles at that point. So here the probability would be out of 10. And since we threw away the red marble, this is going to be 7 out of 10. And the blue one, you can just do 1 minus 7 over 10, 3 over 10. Okay. Now let's do this branch. So we choose red in bag A, blue in bag B, and red in bag A. Okay, so let's go one branch back. So if we choose blue in bag B, the marble is placed in bag A. So because of that, we would have one more marble in bag uh, B. I mean bag A. However, we also know that since we took red from bag A, one marble was already like discarded at that point because we chose red. So by adding one more marble, we get back 11 marbles in total. So here it will be out of 11. And regarding the color, the marble chosen red at the very beginning, that's discarded. And the marble that is put from bag B, that is blue. So the number of red marbles would be 8 minus 1, which is 7, 11. And then for blue, just minus 1 would be 4 over 11. Okay, okay, now let's do this branch. So this one, we choose blue in A, red in B, and eventually red in A. Okay, so here we already did the probabilities for us, so we already know the total number of marbles in bag B, all right? Okay, so since they chose red in here, right? So yeah, they chose red for bag B. That marble is discarded. So there would be one less red marble. So before it was 4. So that means since the numerator is 4, so here it will be 3. Okay. However, from bag A, um, yeah, that marble is also removed, like if it's blue. So because of that, by the time we reach here, we would be remaining with 8 plus 3. 11 minus 1 should be 10 marbles in total. So yeah, 3 out of 10, and then blue would be 7 out of 10. Okay, now let's do this branch. Okay, so we choose blue in all 3 bags. So blue in bag A, blue in bag B, and eventually again blue in bag A. Okay, so since we choose blue in all of them, so from here, there's one additional like blue. You can see 2 out of 6. Right, and then yeah, 2 out of 6. And then a marble is now chosen from bag A. It's discarded if it's blue. It's placed in A. Uh, this one is so yeah, it's chosen blue is placed in bag B. So there'll be one more. And then it's placed in bag A again. So yeah, this would actually just go back to the very beginning where you have 8 plus 3 marbles because you remove one marble and then you add another one again. There's no net change. So 11, 1 over wait, no, 3 over 11. Sorry. Yeah. Yeah, 3 over 11. Yep. And then this one would therefore be 1 minus 3 over 11, 8 over 11. Yeah, so this would be our final answer for the first part. I know it's very confusing, but if but you should like draw out a diagram if it's too hard for you to visualize, or if not, work backwards like what I did. Go to the previous bag. Okay? Yeah, so let's move on to the next part. Okay, so before I start with part B, I made a minor error in part A. So yeah, I basically thought this was the number of red marbles. So that's why I put 3. But yeah, so the idea remains the same. The number of red marbles, remains the same. So therefore, this would be 8 over 10, and this would be 2 over 10. Okay? Yeah, so let's move on. Okay, so for this part, we need to find the probability that all three marbles chosen are the same color. Okay, so very simple. You just take the branch where all three colors are the same. So in our case, this would be red, 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 and blue, blue, blue. Okay, yeah. So let's start. So let's start with the first branch, 8 over 11. So if the probabilities are in the same branch, you multiply them. If they're in one different branch, you plus them, you add them. And then plus 3 over 11 times 2 over 6 times 3 over 11. And this would be 3 over 11 times 4 over 5 times 7 over 10 plus 3 over 11 times 2 over 6 times 3 over 11. So this would be 1307 over 3025. Okay, let's check our answer. If you want, you can also leave it to 3SF, where you get 0.432. Yeah, so this would be our final answer for this part. Let's move on to the next question. Okay, so for this question, we are told that on any given day, Cooper either wears a blue jumper, or he wears a green jumper, or he does not wear a jumper at all. The probability he wears a blue jumper is 0.6. Probability he wears a green jumper is 0.3. Whether Cooper wears a jumper of either color or does not wear a jumper on any day is independent of his choice on any other day. So basically what they're saying is if he wore a jumper, yes, if he wore a blue jumper yesterday, whether he wears a jumper the following day or not, it doesn't like depend on that, okay? Yeah. So for the first part, we need to find the probability that in a week, 7 days, Cooper wears a blue jumper for at least 5 days. So at least is the keyword here. Okay, so for this question, we're given, so our number of trials is 7 days. And within those 7 days, we need to find out how many, like the probability that on at least 5 days, he wears a blue jumper. So since we're given a fixed number of trials, in this case, it's not unlimited, we have a binomial distribution. And the two parameters for binomial distribution are 7. So 7 days, and the probability of success is the probability that he wears a blue jumper. So they already gave that us in the question. That's 0.6. Yeah, so this the distribution will be following, and our x variable would be the number of days he wears a blue jumper. Okay, so the probability that x is more than or equal to 5. So to do this, at least 5 days could mean either 5 days, 6 days, or 7 days. So what we're going to do is we're going to find each of the individual probabilities first. So the probability that x is 5, x is 6, and x is 7. We'll add them up since they're mutually exclusive to find our required probability. So to find any binomial probability of this nature, oh shoot, sorry. You go to your formula sheet, under discrete random variables, you'll see this for binomial. So this is the formula for binomial. So PR, so R is basically the X value. It's N choose R, so N choose X times P to the power of R. So P is the probability of success times 1 minus P, N minus R. So let's copy it down. So N here is 7 and 5. And then probability of success is 0.6 to the power of 5 times 1 minus 0.6, 0.4, 7 minus 5, so square. And then plus 7 choose 6 times 0.6 to the power of 6 times 0.4 to the power of 7 minus 6, which is 1 plus, for 7, choose 7. We know it's going to be 1. So you can just write 0.6 to the power of 7 times 0.4 to the power of 0, which we know is 1. Okay, and yeah, now let's do this. 7 choose 6 times 0.6 to the power of 6 times 0.4 plus 0.6 to the power of 7. Okay, so we got 6561 over 15625. And to 3SF, that would be 0.420. So yeah, this would be our final answer for this part. Let's move on to the next part. Okay, so for part B, we're told to use a suitable approximation to find the probability that in any 150-day period, so this is our number of trials, Cooper does not wear a jumper on fewer than 22 days. So again, since you have a fixed number of days, so within 150 days, we have to find the probability that he does not wear a jumper on fewer than 22 days. So this is a binomial distribution where n is 150 and probability of success, which is wearing a jumper. So to find that, we know it's independent, all right? And the sum of all the outcomes, the probabilities of all the possible outcomes must be equal to 1. So to find it out, you just subtract 1 minus 0.6 minus 0.3. You will get the probability that we require, doesn't wear a jumper, of 0.1. Okay? Yeah, so here they told us to use a suitable approximation. And for paper 5, we only have one approximation to know, which is the normal normal approximation for binomial. Yeah, so we're using the normal approximation to approximate, we're using normal approximation to normal distribution to approximate the binomial distribution. Okay, so to do that, we need to find the parameters of the normal distribution, which is mu and sigma square. So let's find mu first. So mu in our formula sheet is just n times p. So n is 150, p is 0.1. You would get 150 times 0.1, yeah, 15. And then sigma square, that is np times 1 minus p. So 150 times p, which is 0.1, times 1 minus p. 1 minus 0.1, that's 0.9. And for that, you would get 27 over 2. Okay, right. So now we have a normal distribution of mu 0.1 and sigma square 27 over 2. So now we're going to find the probability of px less than 22. All right, yeah. So to use the normal distribution, we first have to standardize it, also known as finding the z-score. So you can't just directly take the value of 22 here. That's a very common mistake. And the reason is because binomial is a discrete distribution, normal is a continuous distribution. And whenever we're, we're using a continuous distribution to approximate a discrete distribution, we have to do this thing called continuity correction, which is basically adding or subtracting 0.5. So in this case, since the inequality sign doesn't have equals in it, we're going to subtract 0.5 from this. Okay, so 22 minus 0.5. And now we can use the formula as per usual. So 0.1, that's a mu over sigma. So that is square root 27 over 2. And now I'll just straight away convert this to a phi. Okay, so 22 minus 0.5 minus 0.1 divided by square root of 27 over 2. You get phi of wait a minute. Oh wait, sorry. I copied it down on this 15 and 27 over 2. So this is supposed to be 15. So 20 minus 0.5 minus 15 divided by square root 27 over 2. You will get phi score of. So for phi scores, oh sure, sorry again. If you go to your normal distribution table, since we're gonna be using these two rows that I highlighted, right? So you can see it's given to 1, 2, up to 3 decimal places. So always round your phi score, your Z score to 3 decimal places. So 1.769. All right. Yeah. So now we are going to use it. 1.769. Oh my goodness. 1.769. 1.769. Okay, so this is 1.7, and then this is 6, and then the last digit would be 9. So 1.7 and 6, we have 0.9608, and then 9, we have 8. So we add 8 to the last digit. So this would be 0.9608 plus 0.0008. Okay, so this would be 0.9608 plus 0.0008. Okay, and your final answer, you must round it off to 3 decimal places. You'll get 0.962 to 3SF. So this would be our final answer for this part, as was the entire question. Let's move on to the next question. Okay, so for this question, we are told that a factory produces chocolate bars, and the weights of the bars are normally distributed with mean 155 grams and standard deviation 6 grams. A random sample of 350 of these bars is chosen. Okay, so for the first part, we are told how many of these 350 bars would you expect to weigh between 148 grams and 160 grams? Okay, so firstly, let's define our variable and what distribution it follows. So we're going to use x. So x is the weight of the bars, and it follows a normal distribution with mean 155 and variance 6 squared. Okay, now we're going to find the probability of x being between 148 and 160. So to find this, you can use this formula. P A between x is Px less than B minus Px less than A. So this is going to be Px is less than 160 minus Px is less than 148. Okay, so since it's a normal distribution, we have to standardize it first. So change it to Z, and then you minus 160 from the mean, 155, over the standard deviation, which is 6, and then do the same for this one, 148 minus 155 over 6. Yeah, so I'll just straight away convert this to phi scores, the phi function. So 160 minus 55 divided by 6, you will get, and for phi scores, always round off to 3 decimal places, because in the table, it's expressed to up to 3 dp. So it's 0.833. And then this would be phi bracket. What's 148 minus 155 divided by 6? You get phi negative 1.167. Yeah, so this is the phi. And then for this week, we see that the phi is, oh my goodness, is in this form, phi minus z. So we use this formula, 1 minus phi z. So this is just going to be like this. So 1 minus phi 1.167. Now expand the brackets and you get phi 0.833 plus phi 1.167 minus 1 and 0.833. Now we'll use the tables. Okay. So 0.833. So the first two digits 0.8, then 3. So you get 0.7967. And then you add 3. 3 is the last digit, so you add 8. So 0.7967 plus 0.0008. Okay, 0.79. Wait, let me see. 7967, okay. Plus 0.0008 plus 1.167. So 1.16, and then you get 0.8770, and then 7, you add here, you add 14. So it's 0.8770 plus 0.0014. So 0.8770. So 0.8770 plus 0.0014 minus 1. And then you get 0.7967 plus 0.0008 plus 0.8770 plus 0.0014 minus 1. So round it up to 3SF, so 0.676 to 3SF. Oh wait, sorry. We don't want the probability here, so you can leave it as whatever your calculator is showing. And then for final answer, just multiply by the total number of bars. So 0.6759 times 350. Okay. Around your answer to the nearest whole number. So that is 237, or you can, do it in the least number, so 236 as well. So yeah, this would be our final answer for the first part. Let's move on to the next part. Okay, so for this second part, we are told that a second factory also produces chocolate bars. The weight of these bars are normally distributed with mean mu grams and standard deviation sigma grams. Tests show that 8% of the bars weighs more than 114 grams and 20% weigh less than 99.5 grams. Okay, so for part B, we need to find the value of mu and the value of sigma. Okay, so to do that, let's find the probability. So let's define the x. So it's the weight of the bars, normal distribution, so mu sigma squared. So the probability of x more than 114 grams, we can convert that into a probability, like whatever percentage they give you. So 8% of whatever more than this, you can say that, okay, the percentage is also the probability of that, right? So hence the probability for this is 0.08. Okay, so let's standardize it. Okay, using our z-score. So to standardize it, we first need to make sure the sign is less than, because our table is it given in terms of like less than or equals to, right? Yeah, so this will be 1 minus p x less than or equal to 114, 0.8. Now we'll make this the subject. So this will be equals to 0.02. Now we're ready to standardize. So this is going to be z less than or equal to 114.0 minus mu over sigma equals to 0.02. And this would be a function of phi, 114.0 minus mu over sigma equals to 0.02. So now we're going to, oh wait, sorry, it's supposed to 0.92. Yeah, so 0.92. So now we're going to use the tables in reverse. So what I mean is, oh my goodness, instead of this, instead of looking at these two rows, we're just going to look at this entire table, like whatever is here, okay? Basically, we're going to find the area. So to find 0.92, you first find the value that is closest to 0.92. So it has to be less than. So in this case, it's this. And to get to 0.92, you can see that you just have to add 0.0008. So you add 8 to the last digit. So look for 8, look for this. And now you can say that your Z value is 1.406. Yeah, so you can equate this to 1.406. And now we are going to make an equation in terms of it. Okay, so 1.406 sigma. Let's make mu the subject. Actually, yeah, let's just keep it as this. Okay. Okay, now let's do the same for the second part, 20% way less than 99.5. So this can be also expressed as probability of x less than 99.5, less than 0. Equals to 0.2, right? Okay, so we can just straight away start standardizing. So z less than 99.5 minus mu over sigma equals to 0.2. And then phi. So one thing that you should realize is that our area here, 0.2, when you go to the tables, you can see the least value is 0.5. So that means this value here is actually going to be negative. So we're going to factor out negative from it. Okay, so you get mu minus 99.5 over sigma equals to 0.2. And to get without the negative sign, just subtract 1 from 0. Just subtract 0.2 from 1. So the 1 minus 0.2, you'll get 0.8. And now we're ready to find it out. So 0.8, let's look for it. So find the closest value to 0.8. So that's going to be me. That's going to be 0.7995. So you can see you just have to add 5 to the last digit. So 5. So that's going to be 0.842. 0.842. So this is going to be 0.842 equals to 0.842. And then mu is just going to be 0.842 sigma plus 99.5. So this is going to be our equation number 2. Now we're going to solve our equation 1 and 2 simultaneously. So we can substitute 2 into 1, and you get 114 minus 0.842 sigma plus 99.5. That would be equal to 1.406 sigma. Okay, so you would get 114 minus 99.5, which is 14.5 minus 0.842 sigma equals to 1.406 sigma. So just add 0.42 sigma on both sides, you get 0.842 on both sides. You would get 281 over 125 sigma equals to 14.5. And then sigma would be 14.5 divided by this. So you will get, I'm just going to put the exact value first because we'll substitute it later to find mu. And final answer would be 6.45 to 3SF. Okay, and now just substitute this to find mu. So 0.842 times 3625 over 562 plus 99.5. Okay, you would get 105 to 3SF. So yeah, these would be your final values for sigma and mu. Okay, let's move on to the final question. Okay, so for the first part of this question, we are told how many different arrangements are there of the 10 letters in the word Seychelles? Okay, so whenever we have a permutations or arrangement question, first thing you should note is the number of repetitions of the number of same letters that we have. So I can see we have 2 S's, so you should note down here, and 2 E's, no, actually 3 E's, yeah, 3 E's. Okay, so Y, okay, no, Y, C also not, H, no, E also not, L, yeah, L also not, yeah, 2 L's. Yeah, so 2 S's, 3 E's. Yeah, so the only non-repeating letters are Y, C, H. Yeah, so these are all the repeating letters. So to find the number of different arrangements, since there are 10 letters in the word, there's obviously going to be 10 total arrangements. So you put 10 factorial over the number of repetitions factorial. So there is 2 S's, 3 E's, and 2 L's. So we also need to divide by 2 factorial and times 3 factorial times 2 factorial. Okay, so just press your calculator. You would get 151,200. So this would be the first part of this question. Let's move on to the next part. Okay, so for this part, we are told how many different arrangements are there of the 10 letters in the word Seychelles, in which there are exactly 2 letters between the S's. So this is one condition. And one of these 2 letters is C. Okay, yeah, so you can see we have 2 conditions to fulfill. So whenever you have this type of arrangement with conditions, you're supposed to sketch out like so you draw your slots first, so 10 letters, so 10 slots for each of them, and place the S's, place the letters in such a way that it fulfills the condition. Okay, so for there to be exactly 2 letters between the S's, we must leave 2 slots empty between them. So one way they can be is right here. Okay, Yeah, so that's that. And then one of the two letters is a C. So C is here, all right? Okay, so the way I like to do this question is to find the number of arrangements that I have for this case that I, drew. Okay, so we can see that 3 of the slots are filled up, so we have 7 free slots where any letter can be. And don't forget to account for your... Okay, so we still have the L's and the E's. Yeah, so without these, for this case, that is just 7 factorial over 2 factorial times 3 factorial. Yeah, so that's like without restrictions. However, we know that that isn't like the only, place that this bundle of letters can be. So now we're going to treat them, you know, as one bundle, okay? And see how many other possible places they can be without breaking formation. So this is one place. So what I want you to do, place your index finger in here and place your middle finger in here. And then, bring each of them one step until your middle finger reaches here. So if you do that, you would get one step, and then one more place, you'll get 2, and then 3, and then 4, and then 5, and then 6, and finally 7. So there's 7 possible places that they can be together. Okay, so you multiply by 7 for that. And we also know that, C doesn't have to be here. It can also be here. And for this case, it's also the exact same as this. So to account for that, just multiply by 2. Okay, so you would get 2 times 7 times 7 factorial over 2 factorial times 3 factorial, which would be 5,880. So this would be our final answer for this part B. Let's move on to the next part. Okay, so for this part C, we are told to find out how many different arrangements are there for the 10 letters in the word Seychelles in which there's an S at the beginning. So this is one condition, and S at the end, and the 3 E's are not all next to each other. So this is the third condition. Okay, so in this question, we have 3 conditions, and one of the conditions has a not in it. So whenever you have a condition with the word not, you find the number of arrangements without the word not. So you find out the case where the 3 E's are all next to each other, and then you minus it from the number of arrangements where the first 2 conditions are fulfilled. Okay, so let's find out the number of conditions where there's an S at the beginning and the S at the end. So let's sketch. So 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so S at the beginning, S at the end. So we can see we have 8 slots freed up. Okay, so therefore we'll have 8 factorial, and we also need to account for the repetitions. So the 3 E's and the 2 L's. Okay, so 2 factorial times 3 factorial. Okay, and then you subtract it from, these 3 conditions except, and then you ignore the not. Okay, right. So now we're just gonna put the 3 E's in an arbitrary place. So let's put it here. Okay. Yeah. So you can see that now we only have 5 spots freed up. So this is going to be 5 factorial, but only for this case. And just like the previous part, since the 3 E's, they have to be together for this case, we'll put a box around them. and then we'll count how many other possible places can they be at. So you put your index finger here, your middle finger here, and then you count all the way until your middle finger reaches here. So you do that. I'm not going to do it again. You'll be like 1, 2, 3, 4, 5, 6. So there's 6 possible ways. So this is going to be 6 times 5 factorial. So this is the number of arrangements where like the three e's are next to each other. So type this whole equation into your calculator. 8 factorial over 2 factorial times 3 factorial minus 6 times 5 factorial. You will get 2,640 as your answer for this part. So let's move on to the final part. Okay, so before I start with this question, I made a minor mistake in here. I forgot to account for the repetitions for the case where the three e's are next to each other. So the repetition in that case would be the two l's. Okay, so over 2 factorial. Uh, so factoring that, we would get 2 factorial. You would get 3,000 as your answer. Yeah, so this would be the, final answer. Let's move on. Okay, so for part D, they said that 5 letters are selected at random from the 10 letters in this word Seychelles. So for part D, we need to find the probability that these 5 letters include the 3 E's. So this question is actually a combinations question because here there's like arrangement doesn't really matter. What matters is the selection, whether we have the E, whether we have the S, whether we have the L, okay? Yeah, so this is not a permutations or arrangements question. All right, so let's find the total number of possible combinations. Okay, so total combinations, you just take total combinations, you just take the total number of letters, so 10 choose, and then since you want 5 letters, so 10 choose 5, type into a calculator, you get 252. Now we're going to find the number of combinations which has all the E's. So let's sketch, okay? So E, E, E. So we have 2 slots freed up. And for these 2 slots, we can choose any letter. There's no restriction. However, after choosing the 3 E's, we would only have 7 letters to choose from. So in this case, so instead of 10, we'll start with 7 and then choose only 2 slots. So 7 choose 2. This would give you 21. Okay, so yeah, therefore your answer would therefore be the number of combinations with this. So 21 over the total number of combinations, 252. So 21 over 252, you would get 1 over 12 as your final answer. So yeah, this would be all. So we have come to the end of this question paper. I hope you found this video helpful. If you did, make sure to like and subscribe and share this video with anyone who might find this helpful. And on that note, I also offer tutoring services. If you need me, you can contact me via email. Okay. Or actually you can go to GCE A-Level Maths' YouTube channel and then fill out your details there, and then please specifically say that you want to be tutored by me, which is the name that you see on the screen right here. Okay, so anyway, that's it. Hope you guys have a nice day, and I'll see you again next time. Okay, thank you.